Hello, everybody. As said, my name is Richard Hartman. I'm talking about JIT Annex. Yeah, that's information about myself. Well, let's get to the beef. Who of you knows what JIT is? Okay, we can probably skip the introduction then. Perfect. JIT Annex is based on JIT. And the one thing which is, well, depending on how you look at it, not good about JIT is that you have to have full history of everything you ever checked into JIT is in every single checkout of this repository. And if you're using this for video or something else, it gets large really, really fast, and you can't really handle it anymore. So JIT Annex is basically using a trick to, we get to that later, to not check the files into JIT, but still manage the metadata about the files within JIT. You are able to use a JIT Annex repository as a normal JIT repository. The two get along just fine, so you can mix and pick as you choose. You are able to retain the full history of all data you ever put into your Annex, but you are not required to. And Joey Hess is living in a small cabin in the woods with solar power and a few batteries. It's really written with low bandwidth and flaky connections in mind, which is really great because, yeah, it tends to work very well even when you are with really shitty internet or no internet at all. And it allows for thousands of different workflows. It's very, very flexible. It's pretty much as flexible as JIT itself. So let's get to some use cases. There are three major use cases which are usually, well, used to present the value of JIT Annex. The first one would be the archivist. He just puts, or she just puts everything into an annex, or several annexes, depending on how you use it. And you can then distribute the data among whichever media you want. It can be tape, it can be a disk, it can be different computers, it can be anything. And you can then simply pull some or all of these media from your computers and store them offline, store them somewhere else in a bank vault, wherever. And you will still have all the information about the actual location of your data in each and every repository. So if you ever need to get a backup of file X, you know exactly, okay, I'll have one copy at my parents' house, and I have one, I don't know, at work, whatever. And yeah, as I said, yeah, okay. Next one, media consumption. That's a rather nice one because, for example, you will miss several talks which you would have liked to watch. That's a really nice use case. And yeah, basically, you simply import whatever data you want into your JIT Annex. And then you can simply copy and sync files around to wherever you're planning to consume them. For example, you may copy a few talks to your laptop to watch them while on the train or on the plane or whatever, and keep the main repository back at home or even on the web. We'll get to that later as well. Once you're done with whatever media you want to consume, you are free to retain it, obvious, but you can also just delete it. And you can tell just JIT Annex, okay, this is a file I will not need again, ever. So you simply delete it, you get your space back, and as you sync between your different Annex repositories, the information about file X has been removed, I don't need file X anymore, will propagate through all your repositories, and you get your data back or your disk space back on all machines without having to think about, hey, I still need to delete this one talk. Yeah. And the last one, which for me personally is the single most awesome thing, basically it allows you to just keep a little subset of whatever data you use on your laptop and keep the largest part back on a server and back home and everything. So you can simply tell your local repository, next time I'm online, I would like to have file X, Y, Z. And once you're back at a reliable internet connection, just grab whatever files, push other files up to back up to your server or whatever. And yeah, don't worry ever again about, did I copy these 5 photos off my SD card and into my storage? Or, yeah, you know, because as soon as it's in JIT Annex will take care of it. Technical details. JIT annex is written in Haskell. It's internally speaking, it has strong typing, and well, the ones of you who know Haskell will know that it tends to produce good code once you get to understand the code, which is quite an effort. Yep. Internally, it uses rsync because there's just no use in duplicating any kind of effort. Rsync does the job of actually transferring the files and ensuring that the files are transferred and have been transferred correctly, perfectly fine or perfectly well. So, yeah. Still, JIT annex will make sure that it's actually there, but yeah, you don't have to do any work twice. It keeps all your objects, meaning files which you put into the annex, in JIT annex objects. Depending on what backend you choose, it may use a different naming scheme, but basically everything you ever put into your JIT annex will reside in there. It will then make the file read-only and put a symlink with the same name, same A time, same C time, everything in place of the file which you just moved away. Using symlinks, by the way, enables you to keep your JIT annex repository itself on your SSD and the annex object store on a normal spinning disk, which is really nice because you get incredible speed, but you don't use up any of your precious SSD space. It keeps a location log about I saw this file at this time on this repository, and at this time it was still okay, and maintains all this data in a specific branch, which means you can always check out this branch, look at it, and do whatever. Also, the branch is very merge friendly, so you can just union merge any branch or any JIT annex branch with any other JIT annex branch, and it's certain to always merge. So it's really trivial to just sync it in the background. The last step is, once JIT annex is done with replacing your files with symlinks and putting everything into place, you simply commit the symlinks to JIT just as normal, which also means that in every other location where you check out, you will see all the symlinks to all your files, but to actually get at the files, you'll have to copy them in once. The fact that files are made read-only is very, very important to how JIT annex works. Because basically what it does, it forces you to consciously tell JIT annex, okay, this is data which is not static anymore. I need and want to write to this data at this point in time. And then afterwards add it back to the annex, which gives JIT annex the possibility to just look at the data, see if anything's changed, and relog everything. So this workflow prevents you from doing any changes by accident and then just forgetting to update the remotes, which would, of course, suck if there's something important there. So you are really forced to make the mental switch to, okay, I'm going to edit this file, and now I'm done editing it. So that's really nice and saved myself quite a few times. And if you want, you can tell JIT annex to just reclaim all unused space, or you can tell it everything which I did have in my repository at some point, I still want to keep. So for example, if you, I don't know, do any kind of post-processing to your photographs or something, you will still be able to maintain all the old versions of your photographs, but still also have the new versions. Data integrity is one very important point for JIT annex, and it's pretty much written around the assumption that your data is important. You are able to simply tell JIT annex, I need X copies of any kind of file. You can just use normal globbing rules. So I don't know, asterisk.jpg has to be there 2 times and all the raw files 3 times or whatever. You can choose between a ton of different hashing algorithms for the backend. And the hashes are actually used and encoded into the file names of your object. So you can even manually maintain or export data if there's anything wrong with your annex. You will always get your data back. That's probably something which I should have posted there at a special point. You will always be able to get your data back out of JIT annex without having to run JIT annex anywhere, every time. So that's really neat. It's able to verify every kind of remote and also non-JIT annex remotes, which are called special remotes and will be shown on the next slide. If you are using a remote JIT annex, you have something called JIT annex shell, which will run all the verification and everything locally, so you don't have to transmit everything via the network. Obviously, if you are using a special remote where JIT annex has no direct control, you need to transfer all the data to make sure that it really is still correct. And this here is basically everything you have to do. Just run it once. When it exits with 0, you're fine and you know that everything is okay. So that gives you quite some peace of mind. Special remotes store data in non-JIT annex repositories, as I already said. It still tracks all the data within the JIT annex repositories. So every single remote will know, hey, there is a Amazon S3 storage which has all my data. We'll come to that now. You can encrypt the remote or the special remotes, which means that you don't have to trust anyone besides yourself. You can just GPG encrypt anything and store it there. Perfect. And a hook system allows you to support any kind of remote as a special remote. Possible remotes include BUP, which is a JIT-based backup tool, which is rather nice. Directory, you can simply export to any kind of media. For example, if you export to an USB stick, which only has WeFAT or whatever. So if you want to export to Windows or whatever your use case, you can just export. rsync is also a special remote, so you can, anywhere where you have rsync support, you can store your data. Amazon S3 Swift, which is OpenStack's compatible version of Amazon S3, and all these cloud storage services can be used. And ThoELAFS is basically a peer-to-peer file system. It's also supported. And then, and that's really nice for talks, you can define web remotes and tell it, okay, there's a talk at http://media.fosdem.org, and that's a talk I want to keep in my annex. And if I ever want to watch that talk, just get it locally without having to look for it. It's all the information I need to get it is on my laptop. So that's basically it. Where can you get it? If you've got Cabal installed, just run this once and everything's fine. You also have native packages for Debian, Ubuntu, FreeBSD, Arch Linux, and NixOS. If you're interested, there's further reading. Now it's time for questions.
With data integrity, do you have to give it different points where it can put the different copies, or where are the different copies put?
So the question was how you tell JIT annex where to put data. Basically, you do the same thing as with a normal JIT repository. You simply clone to somewhere else, or you say JIT annex init. Basically, you say JIT init and then JIT annex init. And then you create a new repository. And you simply define JIT remotes between all the different JIT annex repositories. And they use exactly the same mechanism as JIT uses for remotes. The same is used by JIT annex. So it's the same configuration file, same syntax, same everything. The only thing is you have an additional field, configuration field, which is called UUID and contains the UUID of the one specific remote. And that's all you need, and everything works just as JIT does. Anybody else? So the question was if you can mix the remotes. I'm not quite sure. What do you mean by mix? Okay. Okay. So basically, the question was if you can pick and mix between remotes and special remotes. Yes, you can do whatever you want. You can have one repository with a few talks in a web remote for FOSDEM or for the CCC media server, and in the same repository you can have your contacts to your backup server, to a tape drive, whatever. You can pick and mix as you choose. Anybody else?
I tried to add a remote without adding another Git repository on the remote side. It told me I can't do it. Is it correct that I need another Git repository?
Yes, it's correct that if you want to have a JIT annex remote, the question was if you need a JIT repository in your remotes. Yes, you do, but with special remotes, you don't. So you can use the directory or rsync special remotes, and then you can do whatever.
Okay, thank you.
You told when the data integrity is given, it exits with status 0. What if not?
Then the question was, what if the data is not correct anymore? Basically, what it does, it will tell you what's wrong. And depending on where you are, if you have any other media with the same file, you can just copy it over, or you can even just manually inject it into your backend storage and run another verification run, and JIT annex will simply realize, okay, the data is back, everything's fine again. So basically, wherever else you have your data, just copy it over once again and everything's fine. Okay.
Thank you. And I'd like to push some chocolates to you.